going to use this technique to turn a trinomial and turn it into vertex 4. And we are going to look at how the numbers in front of the equation in the middle of it and the constant at the end give us the value here, here, and there. But before I show you all the process, I want to review this and that with you. How do we expand perfect square? When you are working with a quadratic function, y equals x plus 3 squared. Without the y, you will be able to expand your perfect square by copying the same bracket and expand. You can expand it by FOIL. Multiply it by that. And then you times it by that. X times 3. And then the inside 3 times x. And finally, 3 times 3 will give us a million. Those two middle terms here coming from the outside and the inside will give us like terms. And this is what you'll be getting. X squared plus 6x minus 9. So this is what we would usually get when you expand your perfect square. Once again, we use FOIL to do this. Multiply this by that, and then the outside, then the inside, and then the lost. This is how we FOIL it. And you end up getting 6x in the middle. Using the same concept, when we expand the perfect square of k minus 7, we will have k minus 7 times k minus 7. We have first, outside, inside, and then last. 49. The two middle terms, once again, give us the same value, like the previous example, 3x plus 3x. This time we have minus 7k minus 7k. You will be getting the same term twice before getting your perfect square. So when it comes to multiplying your perfect square, we are getting a pattern in this case. When you multiply this and that together, the k times by k, we have k squared. And then for the middle term, you can see how the outside multiplied to give us 7k. And then the inside, when you multiply the inside together, they are giving us the same value again. And the last term, 49. This number is technically 7 squared. So we have the two examples here. Every time that you are dealing with a perfect square, you are going to get the same number here, here, and there. In this example, we have 7, 7, and 7 after you've expanded. Or in the previous example, we are getting a 3, and a 3 square. So if we can turn a trinomial back into something that shares the same number all the time, you will be able to complete the square and turn a trinomial like this into a perfect square. So this will be our goal. Okay. So looking at these two examples, where do we get the numbers? If we have a trinomial, I turn this trinomial back into the question itself? Every trinomial comes with a middle term. In the first example, we have 6x. In the second example, we have 14k. If you can use this middle term and divide it by 2, you will be getting the number in its perfect square. And not only that, you can also come with the perfect square located at the end. When you divide this middle term by 2, that's the number you'll be using for the perfect square to complete the square. Or for the second example, starting with 14k in the middle, when you divide it by 2, that's the number you'll be using for your